Okay, I'm going to help you with your research today to explain what happened in your inquiry. So in your inquiry today you set up two glasses. One should have been a glass with ice cubes in it, and the other should have been a glass of water without ice cubes in it. Now let's start with the control glass, and this is the glass without the ice cubes. What you should have found was that your glass of cool water, that the temperature went up slowly, okay? Now, if you think about it, I think we know why the glass's temperature would have gone up slowly. Since it's cool water, the air around the glass is warmer. We know that heat transfers from warmer to colder in objects. So if the desk is warmer, there's heat from the desk going into that glass, okay? When the air is warmer, there's heat from the air going into that glass. What will happen slowly is that cool glass of water, the temperature is going to go up, up, up until it is the same temperature as both the desk and the air around it. Okay? So the heat energy is going to transfer into the cooler water until this glass of water is the same temperature of the desk and the air around it. Okay? Because heat transfers from warmer to colder objects. Okay? If let's say our water starts out as 50 degrees, okay, and the room's temperature is probably around 70 degrees, okay, that means that the room is going to warm up the glass, or the 70-degree desk is going to warm up the glass until this glass also is 70 degrees. It's going to give its heat until they're an equal temperature. Alright, I think we've already established that heat transfers from warmer objects to colder objects. So let's go over to this glass. Now this glass is a little trickier. I think you'll find once the ice was in there that the temperature shouldn't have changed very much, okay? Your temperature was going to be about the same temperature until the ice cube was done melting. Now let's think about why, because this is a little bit tricky. So, ice cube. Let's say that our water, again, because the water was the same temperature in each glass to start off with, was 50 degrees. And our ice cube should have been about 32 degrees Fahrenheit. Okay? Since the ice cube is colder than the glass of water, that heat should have been going into the ice cube. Okay? So the heat from the water should be transferring into the ice cube. Now some of you wanted to say that the ice cube gives its coldness to the water, but that's wrong, okay? That is absolutely wrong, because heat transfers only from warmer to colder, warmer objects to colder objects, okay? Or warmer substances to colder substances. So since the ice cube is cooler, it's not going to give its coolness off to the water. That's wrong, okay? The water is warmer, so it's going to give its heat to the ice cube. Now technically that should have made, since the water is giving its heat to the ice cube, it should have made the heat of the whole glass of water go down. But remember, this glass is also getting, that's my wrong color, excuse me. This glass is getting heat from the outside as well, okay? So this glass of water is still receiving heat from the outside, from the table, from the air, okay? So this temperature, all the heat in this glass right now is going to melt this ice, okay? So this temperature of this water is going to stay stable. It's going to stay about the same until, because all that energy is going towards heating this ice cube, okay? Once this ice cube is heated and it's gone, once it's melted completely, then the heat from the table, the heat from the air is going to go in and give its energy towards heating up this water, okay? So the water should stay the same temperature until this ice cube has completely melted. Up until that ice cube is melted, all the heat energy coming into the glass is going towards heating and melting this ice cube. Once the ice cube is melted, then the temperature of the water is slowly going to rise like it's the control over on this side. Okay, now if you're a little bit confused, watch this video again, okay? And then I want you to try to answer our 4 questions for our conclusions and interpretations. All right, thanks.